Pereira. I'm from Portugal Telecom Inovação, and I'm going to present the Fitman project, which is one of the projects of the Future Internet PPP Phase 2. I will present the Fitman, and the idea at the end is to present two different use cases from the 11 total use cases we have in the project. And in these use cases, we will see the requirements for the Internet of Things, for the machine-to-machine, for the cloud. So this is the idea of the presentation. What is Fitman? Fitman is a future Internet technology for manufacturing. It's the full name of the project. It is very interesting that Thomas already presented very well the PPP and provided some thoughts on it. So I don't need to explain or to talk about the PPP in my presentation. Here, the Fitman, as I said, is a phase 2 project. It just started 2 months ago, in April. We are now evaluating the requirements we have for the 11 trials and the generic enablers that the fireware provided has, which we have to use. It's a 29 partners project with, as I said, 11 trials. I will go on some of them later. So the main mission, the objectives of the project is to provide the PPP with a set of industry use cases in 3 different areas: smart, digital, and factory, and then virtual factories. And the idea is to prove and to test, to assess the PPP, the core platform that is being provided by the fireware project. The output of the project, of the Fitman project, is twofold. We will provide a generic platform for manufacturing industries. So we will create a platform based on the generic enablers that the fireware provide and some specific enablers that Thomas already talked about it some minutes ago that are very specific for the manufacturing area. And we will provide that platform for other trials that may reuse it, for example, for the phase 3 PPP. And we will also provide the trials verification and validation framework for those trials. So those two are the main outputs of the project. A very draft architecture that are the basis for us to collect the requirements and to understand which are the generic enablers we will use. So basically in the project we have to build some of the very specific aspects of the different trials we have. We are talking about resource adapters, components that will connect to the different enterprise systems like the enterprise resource planning, the customer relationship management, etc. Then we have those specific enablers that will come from other projects, other European projects, and which are specific for the manufacturing domain, and then the future Internet core platform generic enablers that we will reuse for sure, and that will, with these specific enablers, provide the platform I was just talking about in my previous slide. So, in terms of trials, we have 11 different trials, split in 3 different domains: a digital factory, virtual factory, and smart factory. When we talk about smart factory, we are talking about collecting information from the real-world components. So we want to collect the information from the shop floor, from the machinery in the industry, and we want to quickly react to some of the changes that may occur in the shop floor. This is a smart factory, something in which we collect a huge amount of information, and it will be the basis to reactions in real time. In terms of digital factory, it's about mining of information. It's not so critical in terms of real time, but more in terms of mining on the information that is being collected in the different places, from the shop floor to the management tools, and try from that mining, understand what kind of changes can be done to the processes to guarantee that everything is optimized, efficient in the factory. And then we have the virtual factory that we also call a cloud factory, because in a virtual factory environment, the main goal is for a company is to rent some of the machinery that is not being used right now, and I can rent some time of use to other company to use that machine. So we have the 11 trials split in these 3 different domains: digital, virtual, and smart. In terms of the requirements we are collecting now from the different trials, and I just try to put some examples here, and this is not new from the discussions we had yesterday and we had today, but I tried to group them in Internet of Things, cloud, and data management. From the Internet of Things and the machine-to-machine perspective, we need secure, reliable, and fast communication among the different sensors, objects that are in the shop floor. We need to get real-time information because we have to take some actuation if some event occurs in the shop floor. We have to configure machines, robots, and adapt to changes, and to quickly decide take the best decision in order to actuate in the shop floor. In terms of cloud, these components, as we will see in one of the examples I have in the following slides, they create a lot of information. They send a lot of information to central repositories. So we need cloud for storage, but also for services, because we want to have access to the services and to the data in a high performance and high reliability way. Another important aspect related with the virtual factories is that portability for services and for data is very important to be in place. Okay? Secure portability and interoperability between different clouds that manage the data and the services for the different companies that are trying to share the physical machinery. In terms of data management, very related with the communication between the different intelligent objects, we have to create and to have effective means to filter data, to analyze the information that is being generated in real time. It's very important for some of the trials we have to have the location and mobility aspects of the information we are collecting. For example, one of the trials tries to minimize and to better understand why accidents occur in the shop floor. It's very similar to what João Barros presented yesterday for the taxi and bus. I don't know if you remember that they had that kind of very nice graphs about the people that is driving taxis and buses. It is very similar, but now in the shop floor, trying to understand why people have some accidents in the shop floor more often than others, and what's where is the risk in the shop floor. About social network, it is also an important aspect. It is very related with semantic. It is very important for companies to understand and to get the feel, the mood of the customers, because that information could feedback the innovation and the building of new products for these companies. So, 2 of the trials we have, I have here to present. One of them is Werepool. You all know Werepool. The white goods market, it's highly fragmented. They produce thousands of pieces a day with high number of variations, so it's a very complex production with high degree of automation. So most of the factories are automated, and we have the integration of mechanical and electronic components in those factories. The goals for this trial is to improve the effectiveness of the production system, and to guarantee that the workers in the shop floor react in the fast and effective way to real-time events. So there are three different levels of, let's say, interest when we talk about reaction. If we talk about the operator level at the shop floor, we have to react in 30 and between 30 seconds and 60 seconds, so 1 minute maximum. So it's very important that the data that is being collected and have to be analyzed very quickly, and some answer and decision has to be done quickly. Then we have the supervisor level, which could react in minutes, and then the management level, which could react in some hours. And as you said from the previous requirements, these time constraints put some of those requirements on focus on these kind of scenarios. At the end, we would like to have, with Fitman, we would like to have, and by reusing the different generic enablers, and here we have already a first version of the different generic enablers we think we will use. One related with the Internet of Things to collect the information and to actuate in the shop floor. Another one to complex event processing to guarantee that information is processed in real time and decisions are taken into consideration in real time. And the connection with the different devices, the mobile devices that the workers have in the shop floor. We want to have a close to real data mining to help on decisions. I have some information here. A typical factory like one of the Werepool factories, they create around 600 megabytes a day of information from the different sensors they have on shop floor. So we have to analyze that information, to mine that information, some of that information in real time. And all the elements in the factory will be tracked with RFID technology. The other trial we have here is here in Portugal. Consulgal is a construction company here in Portugal. They are building the Baixo Sabor Dam in the north of Portugal. You have some information about the dam here. It's a big project that will be the base for our trial. And the idea here is to ensure that the project is built according to the design and the specification. This includes multidisciplinary experts, a team very heterogeneous. And it's very important to take the right decisions at the right time. The trial will focus on the concrete test in this kind of environments. The concrete is tested when it arrives to the site, and then it is tested again to check the resistance to compression after 7 days and after 28 days. So that information has to be collected, has to be understood, and has to be available for different players. They have to be available for auditors of the construction, to the creator of the concrete, and to the transporter of the concrete. So the idea is to improve by integrate in a better way all the information that is collected during these tests, is to guarantee a quicker communication and to have speedier decisions and or approvals or rejection of the concrete in the site. So basically, with our project, with Fitman, we will for sure use some of the generic enablers that come from the core platform. You have some of them, the cloud, because we have to store a lot of information, the application markup, and the security/identity management, because we want to create a collaboration platform among the different stakeholders to guarantee that all the people are informed about the tests and could react in the time range that's important for this trial, for this domain. And we want to integrate the designer, the contractor, the supervisor in the process of design, work, and decision-making in all the different steps of the use cases. So those are two of the examples of the trials we have, and the needs, the requirements, these kind of different, completely different use cases put on future internet technology we have been discussing here yesterday and today. Thank you.